In this final video for Module 9, we are going to discuss the nature of mass extinction events and explore the first of the 5 great mass extinctions during the Phanerozoic eon. All species eventually go extinct and new ones evolve. In fact, extinction and speciation approximately balance one another through geologic time. The extinction of a single species is referred to as background extinction, which is happening all of the time. So, what is a mass extinction? There have been instances where extinction occurs rapidly and in many groups. This is beyond the normal background extinction rate. We call these mass extinctions, and they occur across entire ecological systems. So it is not as simple as just counting genera or families. There have been 5 mass extinction events recorded in the rock record of the Phanerozoic eon. Not all mass extinctions are the same. They can have multiple causes and different combinations of causes. Some of the causes can be changes to ocean circulation or ocean chemistry, rapid sea level changes, large-scale volcanic eruptions, or even extraterrestrial impacts. Next, we will look at the Ordovician mass extinction event in more detail. The red line marks the location and time of the Ordovician mass extinction at the boundary between the Ordovician period and Silurian period. This occurred shortly after the Great Ordovician biodiversity event, and biodiversity dropped by nearly 75 marine families. The Ordovician mass extinction occurred 445 to 440 million years ago at the end of the Ordovician period. It is the first of what we call the Big 5 mass extinctions in the Phanerozoic eon. As we have discussed in this lecture, life was flourishing in the Ordovician seas before the extinction event. The invertebrate phyla were joined by early vertebrates in the form of jawless fish. Reef communities were widespread and very successful, but due to the extinction of most reef-building organisms at the end of the Ordovician, the formation of reefs stopped almost completely for several million years. The exact cause of the extinction is not completely clear, but we can take the data that the rock record supplies us with and extrapolate a hypothesis based upon modern conditions. By doing that, geologists have proposed 2 main hypotheses. Hypothesis 1 is the formation of a large continent over the South Pole. When we have continents over a pole, such as Gondwana during the end of the Ordovician, we typically have formation of large continental ice sheets, such as those on Antarctica today. When such quantities of ice form, there is typically a large decrease in sea level. This would ultimately lead to a loss of shallow marine habitat, especially among the sessile benthos who could not move. We estimate from the geologic record that sea levels dropped 70 to 100 meters, and from the fossil record we know that marine invertebrates suffered major losses in biodiversity. Approximately 1 million years after the formation of the continent over the South Pole, the frigid conditions subsided. By now, invertebrates that had survived the first wave of extinction had kind of acclimated to the climate and established new niches. The melting of the ice would basically cause a second blow to life on Earth. When the ice melted and sea levels again rose, water low in oxygen from deeper portions of the water column would have blanketed shallow marine habitats, while the deep ocean completely stagnated. This would cause a second devastating blow to the fauna that had survived the loss of habitat with glaciation. Hypothesis 2 is that a second round of glaciation was caused by volcanic outgassing during the Milbrig volcanic eruptions. During this eruption event, so many aerosols were released into the atmosphere that they essentially placed a shroud over the Earth, decreasing the penetration of solar radiation and thereby causing a dramatic decrease in temperature. This would, of course, have been followed by marine habitat loss again. So we always ask ourselves with these mass extinction events, basically, simply, what died? 26% of all marine families and 60% of all genera went extinct. That is an estimated 82 to 88% of all life on Earth. Remember, families and genera contain many, many species within them. Okay. This is only second to the Permian mass extinction, which is known as the Great Dying. The Ordovician crisis resulted in the almost complete disappearance of suspension feeders such as the brachiopods, corals, bryozoans, and echinoids in both shallow and some deep water areas. Corals decreased by 60%, but these animals did survive and did end up reestablishing themselves later on in the Paleozoic. Some of the factors that led to the mass extinction are the rapid cooling at the end of the Ordovician, sea level changes, and anoxia associated with glaciation. And additionally, there is evidence that this was a biphasic event. So we had more than one glaciation and sea level change event coupled together. Another of the things we ask ourselves with mass extinction is, was the recovery period rapid or was it slow? Marine benthic diversity recovered to pre-extinction levels within about 5 million years. It is likely that adaptive radiation of species into vacant niches played a role in this relatively rapid recovery rate. This is the end of Lecture 9. In our next lecture, we will investigate the age of fishes through the Devonian mass extinction. This is the middle of the Paleozoic.